Are you an engineering or technology related student who is interested or working on a project to teach computers to detect and classify objects? Are you having difficulties with your title proposal? Do you have limited skills in programming but you want to learn how to create a machine learning model? Mga kabulero, I am glad to say that you are watching this perfect video for you. And in this video, I am not only teaching you how to create a machine learning that can detect objects from stored images on your computer, but I will also share the programming on how to classify objects using our computer webcam to detect and classify objects in real time. So the images that I am showing you right now are the images that we are going to attempt to classify using the machine learning that we are going to create. So the machine learning that I am going to share today are the Alexnet and the Googlenet, which are known to be the foundation of the convolutional neural networks, which revolutionized the machine learning. So let's get started with our MATLAB code. I am not going to type in the MATLAB code from scratch. I am displaying it right away and just give you the hints and tips for the lines that I'm going to create for the image classification model. And we will begin using the AlexNet. Just a side note, before I begin this presentation, I already downloaded the AlexNet add-on in Add-on Explorer of MATLAB. But later on, I will show you how to add or to incorporate and run the GoogleNet from scratch, including the installation to the Add-on Explorer. All right. So before we proceed with the classification, we are just going to import our images from our folder to our platform in MATLAB or the workspace in MATLAB. So just drag and drop the images to MATLAB and drag it here to automatically download all those resources for us to be able to include them on our code. And we can now begin with our classification model using AlexNet. If you are interested of knowing the architecture of the AlexNet and all of its parameters and contents, I have a separate video, and you can check the description box for the link so that you'll be able to access it right away. The very first line of our model is the net, and that is just storing AlexNet or the add-on Explorer of AlexNet to our database in accessing the training model. So AlexNet will be stored here, and once we call net, then we are just referring to AlexNet. All right. Now, the second layer or the second level of our model is seeing the details of the architecture. So AlexNet, of course, since it's a machine learning, it is composed of different layers. So I highly recommend that you watch the other video so that you will understand what I am speaking of as of the moment. So we have net dot layers. So we're just accessing the layers of AlexNet. And then we will be reading the image that we are going to classify. For this example, I am showing you all the stored images that we have shown you previously, and we are attempting to classify each of them using our selected architecture or trained model. So on our first example, we have the cat.jpg. And if we check on that cat.jpg, we will be able to determine its parameters or resolution. And the resolution of this picture is 279. That is the width, and the height is 181. But for AlexNet, AlexNet is having another parameter of resizing or adjusting the size of the image, and that includes converting the image or resizing the image to 224 by 224. So since we have 279 by 181, we are expecting to see a squared image right after we implement the image classification using Alexnet. So the size designated by the SZ is equal to the net.layers 1 dot input size 1 is to 2. And that is the code for the IM for resizing the image. And next is, let's classify the image using the AlexNet. Of course, how are we going to know if the prediction or the classification of the model is correct? That is through the label. So we don't have bounding boxes for this type of classification, but in the future, I will be showing you several examples of machine learning, which we are generating bounding boxes for the detection of the object and then classification right after. So in this example, we don't have bounding boxes, we only have labels. So label is equal to classify, net is using AlexNet, of course, IM is our image, which is the cat.jpg. And then at the end, we are going to generate the figure and showing the image and then appending the label. Color is black. We can definitely change it to red, blue, or green. It depends on our preference. So I am very excited to show you the output of this code. And now let's run this code. It's now showing you, of course, the layers that we have pulled out earlier. And this is the architecture of AlexNet. And look at this one, categorical Persian cat. It's very specific that it's not only showing the label as cat, but it also has its breed, which is a Persian cat. All right, so let's run another example. Let's try to use the dog, and that's still a JPEG format. Let's change the cat to a dog and run the code. Running only takes like several seconds. So this is a German Shepherd, right? This is pretty exciting. And we are not creating AlexNet from scratch. We are just pulling out its architecture and then implementing it using this. How many lines of codes? Actually, it's not a bunch of codes. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 layers of code, and it's pretty showing a good outcome from the classification itself. So let's try the last example that we can have here. Let's try the hug. All right, so the hug is this one, right? And then let's see how it performs. And it's an Ibizan hound. It's not only showing a hug or a pig, right? It's also the breed of that pig. And now we are going to move on to GoogleNet. And this time I am also excited of showing you the output of this one because we are creating or we are installing GoogleNet prior to running the code. So if GoogleNet is not yet added or installed to your add-ons in MATLAB, you will be receiving or you will be seeing an error message. So let's clear out the command window first. Okay, so it's now cleared, right? Let's give this several spaces so that you will be seeing the code on top. All right, so let's try running this code because I have declared the net here or the trained model as GoogleNet, though I don't have the add-on to my computer yet. So let's run this code and let's try to see what the error message looks like. So running the code. Boom. So error using GoogleNet. GoogleNet requires the deep learning toolbox model for GoogleNet, blah, blah, blah. So error in digital image processing codes, net is equal to GoogleNet. So it is pointing out that GoogleNet is not yet added as an add-on. So add-on Explorer is located here as a hyperlink. And what we need to do is just click on this hyperlink. A box will appear and it shows the button where we can click on and install the resources. All right, so it's the deep learning toolbox model for GoogleNet Network. It's very convenient that MATLAB is showing this error code with the hyperlink so that we are not going through so many steps like searching the documentation and then looking for the deep learning toolbox model out of it. So here we just need to click install. You have options to install or download only, but we need to install to run the code properly. So we are waiting for several seconds. I'm not so sure if this will take minutes, but it depends on your internet connectivity if it will be downloading it faster or slower. But the size of this is 8.2 kilobytes. So hopefully this will just be downloaded in an instant. Okay, downloading support packages, and then right after they'll be installing the support packages. And finally, configuring your installation. So what we are expecting if we use GoogleNet, we might see different labels compared to the Alexnet because Alexnet may have different sets of classification labels compared to GoogleNet. And that is the distinction between multiple machine learning or deep learning algorithms. They differ on the data set, the compilation of the data set, and also its labels inside the data set. And for sure, in the future videos that I'm going to create, I will be showing you Coco dataset, which is used for a much more higher deep learning algorithm, and that includes several hundreds of data sets in it. And while we are downloading, I'm just speaking at random. So it looks like the installation is complete. Let's close this out and try to rerun the code of our image classification model using GoogleNet. So let's clear this out, clear all CLC. Now, after clearing the command window, we now can see that we have here almost the same line of codes with Alexnet. We loaded the GoogleNet architecture in our net variable and then calling out the net variable as net.layers and then classifying the image or loading the image for classification, and that is IM is equal to IM read. And then I have here the sample mouse.jpg. This is not the mouse or the rat, but this is a mouse used for clicking. And then adjust size of the image, same resizing the image. And both AlexNet and GoogleNet has the same resizing architecture or requirement, which is 224 by 224. So let's see. Now the label classify net is it the comma IM. And then here, let's try using other color. Let's try using red. Okay. And let's run this code. I'm excited what this classification would look like. So run this section and it has this layer. Oh, I think the red text is not appropriate. It's not too visible in this view. So it's a mouse, right? And let's try using other picture. I wanted to see the pug. Okay, the pug is this one. Looks like the picture has been, okay. The pug is this one. So the resolution of the pug is 1200 by 900. It's a huge resolution, but definitely it will be resized to 224 by 224 using this code. And then let's try what this image classification would predict this picture. And boom, it's a pug. And the red is appropriate for this picture. All right, so this is really exciting. The last sample that I want to show you is let's try the airplane. I'm not endorsing Cebu Pacific on this video, but Cebu Pacific, baka naman. All right, so that is airliner. Okay, so as promised earlier, I am not only showing you the classification results using the images that we have stored on our computer, but one of the great things about classification using convolutional neural network or CNN is that we can use the model and then use our computer components such as our webcam to detect real time, right? So I have created here another um, line of codes or set of codes just to show you that we can use the Alexnet and Googlenet to classify objects in real time. I only have one item to show you as an example of the classification um, because most of the objects that I tried feeding as a live or the real-time classification for these models, those are creating misclassifications. And I don't want to show you uh, classification in error or misclassification so that you'll be able to be inspired of using this model as a beginner, right? But if you want more advanced classification models for your training or for your thesis or your maybe master's theses, then you can definitely use other classification models that has a high accuracy or precision, right? But in this example, what I'm going to show you is the code to implement a real-time classification of object using your webcam. So the first line here, of course, we are loading AlexNet to net variable. Then we will be loading the architectures, the layers that we have seen previously in our examples. All of these are the layers. And the third code is read image to classify by loading your webcam info. In here, I have declared my webcam name. And if you don't know your webcam name yet, the code for checking the webcam code or the webcam name is, let's clear this out first. The code is web, or let's have a variable that is cam. The code is webcam list. All right, so let's run this code and that will show you. Actually, we can um, type it right away here on our command window. That's it. No need to open up another tab there. So using webcam list, the MATLAB only detects one webcam on my computer. But if you have an external webcam that you can use to, of course, move from different places or navigate through different points of view to check on images, and therefore you can see multiple or two or three inputs for your webcam, right? But for now, what I can see here as the name of my webcam is HD user facing. All right. And that's what I inputted here as my webcam name. And then I here is the iteration of capturing images, because loading a real-time video feed in MATLAB is just capturing multiple snapshots or images with intervals. So we will be declaring intervals right here using several lines of codes, and I'll be sharing it to you in a minute. So next line here is while true, load the code for capturing the image, like IM is equal to cam dot snapshot. And then this is the code where we have used or implemented our learning from previous videos. This is about contrast stretching, right? And the code is I am local brighten, just to give more lighting to our image if we have a dimmer colored image in our using our webcam. And that is pretty usual if you're using your webcam, you have a very low light resolution of your image. Now, adjust the size. I'm not discussing this further. We're done with this previously. Classify the object. This is the label. And then show the image and classification results, figure, and then same goes with what we've done previously. But the additional line item here were pause. We will be having a pause right after a snapshot so that our image classification model will not capture images very fast. But what we want here is just to take a single picture and then try to check the classification result or prediction. And then this is the iteration I+1. And then that ends our program. So I'm excited to run this code. And for sure, this is a live feed from my camera. I don't want to see my face on the picture, but the object that we want to capture at this time is a toilet paper or a paper towel. So let's run this code and try to check what's the result. All right, so let's try to run this code. And this is a live feed from my webcam. And we're expecting it will open up our camera. There you are. And of course, it shows as a toilet paper. So let's stop the program and do some wrap up. So to summarize what we have discussed today is we have created a machine learning or an image classification model using Alexnet and Googlenet. And we don't share only the code for classifying objects from our stored images, but we also showed you how to create a machine learning in classifying objects real time using our webcam. So if you want more information about machine learning using AlexNet and GoogleNet, you can definitely check the description box for the link to this as a discussion of the architecture and also the components of the machine learning or the called convolutional neural networks. This ends my presentation, and I hope you were able to learn so many things about machine learning using AlexNet and GoogleNet. Thank you so much.